So our today's topic related to nernst equation, उसके related numericals करेंगे हम, okay? And then different formulas we have used. First is A moles of A when react with B moles of B gives C moles of C and D moles of D, and if n electrons are involved in it, then E cell equal to E naught cell minus 0.0591 over n log of product over reactant. Then delta G naught is related to E naught cell by this relation, delta G naught equal to minus NF E naught cell. Or third one is E naught cell equal to 0.0591 over n log of Kc. These are the three formulas we'll use to solve the numericals, sample as well as numericals. So let's do it. Of the video. First question is, represent the cell in which the following reaction takes place. So see, in this particular cell, Mg solid gives Mg2 plus. So that means Mg solid to Mg2 plus. So it uses 2 electrons, his oxidation takes place, and at the same time Ag plus gain 1 electron to give Ag. So it should be multiplied by 2, and on silver reduction takes place, and then we use this formula alone. Left side oxidation takes place, and that acts as anode, and that has negative sign. So that means magnesium, and magnesium oxidation takes place, so it should be on the left side, and this is salt bridge, then Ag plus to Ag. This is the cell representation. It is written represent the cell in which the following reaction takes place. So first we have represented the cell, right? Anode on the left, cathode on the right. On the anode oxidation takes place, at cathode reduction takes place, and these ions have the concentration Mg2 plus 0.130 molar and Ag plus 0.001 molar. Now to write the nernst equation, so you can write according to nernst equation. You know, this is the reaction. So E cell equal to E naught cell minus, better to write 0.059 over 2. Write it like this. Simply E cell equal to E naught cell minus 0.059 over n. So n for this particular reaction is 2. Log of product. What is product? Mg2 plus raised to power 1 and Ag plus raised to power 2. So 0.130 divided by 0.0001 raised to power 2. In this way, see, E naught cell is given to you. It is 3.17 volt minus 0.059 volt over 2, and log of 0.130 over 10 raised to power 10 raised to minus 4 raised to power 2. So solve it separately. The log of 0.130 divided by 10 raised to power minus 4 raised to power 2, it is equal to log of 0.130 divided by 10 raised to power minus 8. So in this way, it is log of 0.130 into 10 raised to power 8. So log of 1.3 into 10 raised to power 7. So it is log of 1.3 plus log of 10 raised to power 7. So log of 1.3 plus 7, log 10, and log 10 is 1. Okay. So what is the value of log 1.3? That you can calculate by using the calculator or log of 1.3. So yes, beta, what is the value of log of 1.3? Would be 0. And we'll look at log 1.3. First we count the digit before decimal place, that is only 1, therefore it is 0. And then value comes out to be is 1.3 10 raised to power 7. So comes out to 7 log 10. So log of 1.3. See the value of log of 1.3. Good morning, beta. Daspur. Yes, please write the value of log of 1.3. I don't have log. One point three. It is 0.113. 0.114 we can write. 0.114 plus 7. It is 7.114. So in this way, E cell equal to 3.17 minus 0.059 by 2 into 7.114. So it is into 0.059 divided by 2. Seven 7.114 into 0.059 and divided by 2. So it is 0.209, means 0.21 volt. In this way it is 3.17 volt minus 0.21 volt, and that should be equal to 2.96 volt. Got it? Yes, it is 0.113 something. That's why it is 0.114. Okay. Now next question is the calculate the equilibrium constant of the reaction. Again, in this particular reaction, value of N is, what is the value of N? Because copper to copper 2 plus and Ag plus, there are 2 Ag plus 2 Ag, so N is equal to 2. So to calculate equilibrium constant, so we will write the equation for the relation between E naught cell and equilibrium constant. This is the relation E naught cell equal to 0.059 over N log of Kc. So E naught cell equal to 0.059 over N is 2 log Kc, and E naught cell is given to you, that is 0.46. This way log of Kc, that is equal to 0.46 volt into 2 divided by 0.059 volt. So it comes out to be 15.6. So Kc is antilog of 15.6. So in this way, the number before the decimal place is written in 10 raised to power 10 and antilog of 0.6. So antilog of 0.6 is, yes beta, what is antilog of 0.6? 1, it is 0.6 and it's antilog. So antilog of 0.6 is, it is 3.98. Given as 3.92, but it is 3.98. It's okay, 3.92, or we can write it as 3.98 because 0.059, if it is taken as 0.0591, maybe value is 3. Very close to 3.92. It is Kc is 3.92 into 10 power 4, and if we write it approximately 4.0 into 10 power 15, that will also be okay, right? So this is question example number 3.2 in your NCERT book. 3.3 standard electrode potential for Daniell cell. What is Daniell cell? Zinc copper cell. Daniell cell is zinc copper cell. Okay, zinc copper cell is called Daniell cell, and zinc plus copper 2 plus give sorry, zinc 2 plus copper. So delta G naught we have to calculate. Standard gives energy. So for calculating standard gives energy, you know, delta G naught is equal to minus NF E naught cell, and value of N is 2, F is 96487. Approximately you can take it as 96500 coulomb per mole. And what is 1 Faraday? 1 Faraday is, it is charge on 1 mole of electrons. Charge on 1 mole of electrons, and that can be calculated as, you know, is 1.602 into 10 raised to power minus 19 coulomb, and it is charge on 1 electron. On 1 mole it is 6.022 into 10 raised to power 23 particles electrons per mole. In this way, when we multiply, the value comes out to be nearly 96487 coulomb per mole. E naught cell is also given, just multiply. So coulomb into volt, that is equal to joule. Coulomb into volt is joule. Okay, so joule per mole, right? Now, next question for you. Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. See, hydrogen electrode. So in hydrogen electrode, you know, reaction taking place is H plus electron to give half H2 gas. Now pH is given to you. Let us write first its equation, Nernst equation. So according to Nernst equation, E H plus H2 PT is equal to E naught H plus H2 PT minus 0.059 over N log of product over reactant. Now, as pressure is not given, so whatever is not given, we will take it as standard. So pressure is taken as 1 bar, and pH is given to you. So pH is minus log of H plus ion. That implies log of H plus is equal to minus 10. H plus is 10 raised to power minus 10. And E naught value for hydrogen electrode is, because it is a reference electrode, its value is 0. So that implies E H plus H2 PT equal to 0 minus 0.059 over 1 log of 1 upon H plus. It is minus 0.059 into log of 1 upon 10 raised to power minus 10. It is minus 0.059 into log of 10 raised to power 10. So it is minus 0.059 into 10, means it is minus 0.59 volt. So this is the value of electrode potential of hydrogen electrode. Okay. Got it, beta? Done? Any doubt in it? कर लोगे? Okay, so next question, because 3.1 to 3.3 in text questions we have done in our previous class. Now 3.5, calculate the EMF of the cell in which the following reaction takes place: nickel solid plus 2 Ag plus 0.002 molar to give Ni2 plus 0.160 molar plus 2 Ag solid, and E0 cell is given to you. So first of all, we will write the cell reaction is Ni is solid plus 2 Ag plus 0.02 molar to give Ni2 plus 0.160 molar plus 2 Aj solid. So according to nernst equation, E cell is equal to E naught cell minus 0.059 over n. So what is the value of n here? Can you tell me? Yes, beta. What is the value of n? What is the value of n in this particular reaction? Yes, beta. Value of n in this particular reaction. So n value is 2 log of product over reactant, because solid are neglected, ignored, because their value is taken as unity. So now E cell is equal to 1.05 volt minus 0.059 volt over 2 log of Ag plus, sorry, nickel 2 plus. So it is 0.160 divided by 2 into 10 raised to power, yes beta, 0.002. So it is 2 into 10 raised to power minus 3 raised to power 2. So in this way, it is 1.05 volt minus 0.059 volt over 2 log of, take it as 16 into 10 raised to power minus 2 divided by 2 to the 4 into 10 raised to power minus 6. So in this way, it is E cell equal to 1.05 volt minus 0.059 volt by 2 and log of 4 into 10 raised to power 4. So it is 1.05 volt minus 0.059 by 2. Now what is the value of log 4 into 10 raised to power 4? So take separately, solve it. So log of 4 into 10 raised to power 4, that is equal to log of 4 plus log of 10 raised to power 4. So it is log of 2 raised to power 2 plus 4 log 10. So it is 2 log 2 it is 2 log of 2 plus 4. So it is 2 into 0.3010, but better to write it as 0.3 only, plus 4. So it is 0.6 plus 4, that is it is 4.6. So that implies this value comes out to be 4.6. So it is 1.05 volt minus 0.059 volt into 2.3. So just multiply 2.3 into 0.059. So it is 0.1357. 1.05 volt minus 0.1357 volt. So 1.05 minus 0.1357. So it is 0.9143 volt. So E cell comes out to be 0.9143 volt. Is it okay? Yes, beta. Any doubt? Okay, so next question is, the cell in which the following reaction occurs: 2Fe3 plus aqueous plus 2I negative aqueous to give 2Fe2 plus aqueous plus I2 solid, has E0 cell 0.236 volt at 298 Kelvin. So calculate the standard Gibbs energy and the equilibrium constant of the cell reaction. Standard Gibbs energy. So to calculate standard Gibbs energy, relation is delta G naught is equal to minus NF E naught cell. So in this particular reaction, value of N is 2, value of F is 16. Better to write 96500, but as in NCERT it is given as 96487. So you can write it as 96487 coulomb per mole. Okay. Okay, coulomb per mole. Okay, and then E0 cell, it is also given to you 0.236 volt. So just put the values in this particular equation. So delta G naught is equal to minus 2 into 96487 coulomb per mole into 0.236 volt. So coulomb volt is joule. So value is 2 into 96487 into 0.236. So it is 45541.864. So better to write it as 45541.864 542 joule per mole. So in kilojoule it is 45.542 kilojoule per mole. Okay. Now to calculate the equilibrium constant, E naught cell is equal to 0.059 over n. N is 2 log of Kc. So that implies log of Kc is equal to 2 into E naught cell by 0.059. That implies Kc is equal to anti-log of 2 into E naught cell by 0.059. So it means Kc is anti-log of 2 into 0.236 divided by 0.059. So it is 2 into 0.236 divided by 0.059. So it is round about 8. 2 into, I will do it once again, 2 into 0.236 and divided by 0.059. But better to write, because if it is 0.059 taken as, so it becomes 7.98 only. So 7.9865. 7.9865. So Kc is, sorry, anti-log of 7.9865. So it is 10 raised per 7 into anti-log of 0.9865. So it is 9.69 into 10 raised per 7. That's it. Okay. So that's all for the day. Thank you so much to all of you. Bye bye beta. Okay.